336 is basically an exercise in knowing whether or not you know your ionic charges. They want you to make a formula given the two compounds with a given color. For example, they ask you to give the likely formula for the compound in red. So they're talking about the element there and the element there. And this is where a little bit of battleship comes in. This would be period 4. This would be group 4A, and it would be period 1, 2, 3, 4, 5, 6. So we're looking for the element in group 4A, period 6. So I'm going to open up my periodic table. Period 4A, group 4A, period 6 would be lead. So lead is one of my elements I'm going to be using to make the compound with. Then my other element in the compound is going to be in period 5, 6, so it's going to be in group 6A. And third period. So who's third period? 6A. So I come over here, third period, 1, 2, 3, group 6A, and my other element's sulfur. Now I know that sulfur wants to be 2 negative. Lead, and this is where it can get a little bit tricky, lead can actually have more than one possible charge. It could be a 2 plus, or it can be a 4 plus. Well, it's pairing with something that's 2 negative, so it makes life simple for us if it turns out to be PBS for our compound. If you put PBS2 on an exam, I'd count it right. I don't think the computer program will for this one, because lead can be actually a 2 or a 4, so they really shouldn't have used lead in this example. But let's keep going. The next thing they ask us about is the blue compound. So blue, we're looking at element 7A, and we're looking at 7A second period. 7A second period is going to be fluorine. So fluorine is going to be one of our elements. And remember, fluoride always has a -1 charge. The other element we're going to be going for is going to be group 2A, and it's going to be 1, 2, 3, 4, 5th period. So it's going to be strontium. And strontium's in group 2A, so it has a +2 charge. Ionic compounds always form so they're electrically neutral. So if strontium and fluoride were going to form a compound, it would take 2 fluorides to cancel out the positive charge on the strontium. So you'd wind up with strontium fluoride. If we continue, how about our green compound? Once again, we're going to need to locate our elements, so let's locate our elements. Green's right there. It's in 4A, second period. 4A, second period. Carbon. Then it's combining with, who is it going to pair with? It's going to pair with group 7A, second, third, fourth period. So group 7A, fourth period. Group 7A, fourth period. 1, 2, 3, 4. Fourth period would be bromine. Alright, so what compound is bromine and carbon going to form? We've got 2 nonmetals. We don't really have a rule yet to govern 2 nonmetals, but let's just think about it from terms of the octet rule. Carbon has 4 valence electrons. Bromine has 7. So each bromine needs 1 electron to obey the octet rule, and carbon needs 4 electrons to obey the octet rule. So what's going to happen is a bromine is going to share one of its electrons with a carbon to form a covalent bond. Then another bromine will come in and do the same thing, and another bromine, and another bromine. So the answer for that one would be carbon tetrabromide would be your compound.